Hey, mathematicians. This is Mrs. Shopper coming to you with Unit 8. It's our 3-day unit. It's going to be a super quick one. It's going to be all about line of best fit. We're going to be talking about scatter plots and correlations and how to draw a line of best fit, build on our equation solving that we've been working on and equation writing. So here we go. All right, so what is a scatter plot? A scatter plot shows the relationship between a set of data with two variables, all right? They're graphed at ordered pairs on a coordinate plane. So if you look at these examples here, these are all examples of scatter plots. You've got your x-axis, which is your independent variable. You have your y-axis, which is your dependent variable. And so that's a scatter plot, just puts the data all over. Then there's something called correlation. And correlation shows the relationship between those variables. You can have a positive correlation. That means that it trends upward from left to right. You have a negative correlation, which means it trends downward left to right, or no correlation. There's no connection between the points at all. All right. So those are the different types of correlations that we can talk about. So let's go through here again. It's very similar to what you saw here. Some examples. Positive moves upward left to right. Negative moves downward left to right. And no correlation is really just kind of all over the place. All right. So that's correlation. All right. It's either positive, negative, or none. Now, how do we create a scatter plot? Well, this is an example of a history teacher asking their students how many hours of sleep they had the night before a test. And then what this teacher did is they compared the number of hours slept with the test score. All right. So what we want to do is plot that data on this graph. And so, like hours slept was 8. I've got 83. Hours slept was 7. We've got 86. Hours slept is 7. I just realized I put those on 2 of the wrong spots. So 86, 83, 74, 8 and 88. We've got 6 and 76. So I'm finding where my dots connect, 5 and 63. So I go over 5, up 63, over 7, up 90. Kudos to that student. Over 4, up 60. Over 9, up 89. And over 7, up 81. So what we do is we plot that data. All right, so we've got it plotted. There's some trend I can see in that case. It seems to trend upward, left to right. All right. So this is how you create a scatter plot, and this has what we would call positive correlation. All right, and you've created scatter plots. I believe most of you, if you've come through prior Lake Savage, created scatter plots where you take your data and you put it on a grid. Okay. So here, what relationship exists between the X and the Y variables? What kind of a correlation is it? Okay, so this is because this one moves upward, whoops, that's not what I wanted to hit. Hits upward left to right. This is what we would call a positive correlation. All right, this particular one is moving left or downward left to right. So as a car ages, its values are coming down, its value is. So we call this a negative correlation. All right. Taking a look at these, again, I'm starting to see a positive correlation between study time and average test score. So I'm seeing a positive correlation. When I take a look at the age of a student and the size of their shoes, it's really kind of all over the place. So there is no correlation here. And when we look at the number of TVs sold and the price per TV, as we sell more TVs, the price goes down. So we call this one a negative correlation. All right. So far we've talked about correlation and we've talked about how to create a scatter plot. Now, what we're going to do is we're going to look at different scenarios without a graph. So looking at a specific story, a scenario, all right? So how does the number of people at your party and the amount of food you have to buy correlate? All right. So as the number of people increases, what happens to the amount of food you have to buy? It's going to increase, right? The food is going to increase. If the food increases, both of them are increasing. So we say that that is a positive correlation. As one increases, the other is increasing as well. The amount of pets in your home and the amount of clouds in your sky. They're not really related at all. So there is no correlation, right? The number of clouds outside has nothing to do with how many dogs we have in our house, which is one, by the way, right? No correlation. The age of an elementary student and their height. I could go a couple different ways on this one. One way I could think is none. Because I mean, take a look at your peers, right? Like you have tall people, we have short people in 8th grade. That's just kind of how it works. So part of me is like, I don't think there's a correlation. And then part of me is like, well, as people get older, they tend to get taller. So I would say a positive correlation. So this one's kind of a tough one for me. I would have to say none or positive. And this is where having an explanation would help me understand where you're coming from. The number of times a student is absent and their grade in math. All right. I would say typically the number of times that a student misses a class or misses a Google Meet means that their score on their assessments are going to come down because they're not getting the learning that they need. So I'm going to say for this one, in most cases, this is going to have a negative correlation. The more you miss, the less you understand and the lower your grade's going to go. All right. Type of correlation, the number of Girl Scout cookies I eat and the temperature outside. There's no connection, right? There's no connections at all. There's none. The temp outside and Girl Scout cookies? Nah. All right. How about this? The time I spend working out and the amount of calories I burn. Well, I'm hoping the more I work out, the more calories I'm going to burn. So I'm going to have to say that this one is a positive correlation. All right. As one increases, the other is increasing the same. All right. So just a little bit of review before I give you some time to work. Write these equations in standard form. Standard form is ax plus by equals c. I need x and y together. So I'm going to start by subtracting 3x from both sides. So negative 3x plus y equals negative 4. And then I have to go back to my rules about standard form. A, B, and C have to be integers. Check. A needs to be positive. Ooh, all right. Time to divide everything by negative 1. So 3x minus y equals 4. And it has to be written in simplest form. Check. So here is standard form. All right, let's take a look at the next one. Ooh. Y minus 6 is equal to 2 times the quantity x plus 5. I need it in standard form. First thing I'm going to do is distribute. So y minus 6 is equal to 2x plus 10. Now I need x and y on the same side. So I'll subtract 2x from both sides. Negative 2x plus y minus 6 equals 10. I'm going to add 6 to both sides. Negative 2x plus y equals 16. So A, B, and C have to be integers. They are. A needs to be positive. Ooh, got to divide everything by negative 1. I'm going to move it over to here. So I end up with 2x plus negative y equals negative 16. Has to be written in simplest form. It is. So here's the final equation. All right, standard form. All right, we're going to just take a moment here, 2 more. We're going to rewrite them in slope-intercept form. This is what we just got done working with. Slope-intercept form is y equals mx plus b. All right, so I have to get y by itself. So I'm going to move 4x plus y, 5y over here, so I have a little more room. I need to get y by itself. So I'm going to subtract 4x from both sides. So 5y is equal to negative 4x plus 10. Again, this is the work we were doing in parallel and perpendicular lines because we wanted to get it into slope-intercept form to figure out the slope. And then I'm going to divide everything by 5. So y equals negative 4/5 x plus 2. That is my equation in slope-intercept form. Y equals mx plus b. All right, one more example and then you get some work time. Here we go. I'm going to distribute. We always distribute first when we're rewriting or working with equations. So y minus 4 equals 3x plus 15. I'm going to add 4 to both sides because I already have x away from y, which is fantastic. So y equals 3x plus 19. All right, mathematicians, it's time for you to work on 8-1. Have a good day. Take care. Bye.